Hey guys, we saw in the last two videos how to create groups and then how to read data from groups within HDF5 files. And in this video we're going to be looking at how to use compression, how to compress the data whilst we're saving it so we can save size. And the data we're going to use here is exactly the same, the code here is exactly the same as the one in the last two videos when we imported NumPy and H5Py. We created four matrices, 1000 by 1000 matrices of random numbers, and then we're just here creating a HDF5 file. I'm calling it HDF5 groups compressed.h5 on my desktop, and I'm creating the exact subgroups we saw in the last two videos. If I run that, it'll create this file and save it on my desktop. And you notice here for the create dataset method, we give it a name or shape and then data, and you notice in the documentation we can also specify compression. So what is the compression algorithm or the compression strategy? And we have three values: gzip, szip, or lzf. And then we have the compression opts, which is just an integer for gzip between 0 and 9, so the level of compression, or how much compression between 0 and 9. So I have set these already here, as you can see, into the dataset function. I give it a name or key, and then the value is my data matrix 1, and then compression I said gzip, and then compression opts, which is the level between 0 and 9, I say 9. Likewise here 9, 9, 9, and the same algorithm. So let's run the code and see what happens. Remember, these are random numbers, so compression, I don't expect compression to be very good anyway. If this was text, then compression we expect it to be really good. But let's have a look at the sizes. So the size of this compressed file is 29 megabytes, and the size that of the file we created before, the same file without compression, is 31 megabytes. Or in fact, we can compare the exact same one. So we run it again, and the size is 29 megabytes. If we remove the compression quickly, let me pause the video. So we remove the compression. If we run it again, have a look at the size of the file, it's 31 megabytes. So like I said, it's not expected to be a big, we're not expected to save a lot using compression here, because the data itself is numbers. So the nature of the data is the reason behind that. And then you can experiment with other compression algorithms, the ones we saw. We have gzip, we have lzf, is it? Where is compression? Yeah, lzf and szip. Okay, so let's stop here. That's how you can compress data. In the next video, we will start looking at how to do HDF5 files using pandas, which is great and powerful. So let's stop here and see you next time.